Hello students, welcome to the session. Welcome to Infinity Learn NEET channel. How are you? And today we are going to discuss about aromaticity. Aromaticity means the compounds do have a characteristic aroma. Aroma means smell. Actually, aromatic compounds do have a specific characteristic aromatic smell. So we'll go into the details of aromatic and aromaticity. This aromaticity gives at least 1 mark from the total arenes related to concepts. And this aromaticity is very important for NEET examination point of view, and I am going to unfold this in a simple, at least in 10 minutes you are going to know about the aromaticity details. Aromaticity, let us talk about the reactions of alkene. This is your cyclohexene. This is a simple example for the alkene when it is treated with alkaline cold KMnO4, which is a Bayer's reagent, which is in the pink in color. When this react with this cyclohexene, it is going to give rise to vicinaldiol. Due to that, the pink color of the KMnO4 is going to be disappeared. So what I mean to say, cyclohexene when react with the cold alkaline KMnO4, the pink color is going to be disappeared. This is the fundamental test for unsaturation. So alkenes or alkynes do behave like this. Now what if benzene is treated with a KMnO4? So when benzene is treated with KMnO4, it is not going to react with KMnO4, alkaline cold KMnO4, because of this delocalization of pi electron system. It acquires a characteristic property called aromaticity. That's what I want to say. When benzene is reacted with alkaline KMnO4 in the cold condition, there is no reaction. So this, however, though it has 3 double bonds in benzene, it do not react with KMnO4 due to a special character called aromaticity. So we will go into the details of aromaticity. So the aromaticity, the ring in the electron continuously revolve in a circular path, and it is delocalized above and below the ring, so that delocalized system resist the addition reaction, rather it undergo substitution reaction. And this is attributed to the aromaticity, and this aromaticity in the direction of ring current is diatropic, then the molecule is said to be aromatic, and the ring current is going to be paratropic, then it is going to be anti-aromatic. Now let us see the details about the classification of the cyclic organic compounds. The cyclic organic compounds are basically divided into aromatic, anti-aromatic and non-aromatic. Let us see the details about the aromatic and conditions for the aromatic. And there has to be a ring structure, and there should be a planar ring structure. How do you decide the planar ring structure? Every atom in the ring should be sp2 hybridized. It shouldn't be sp3 hybridized. And this particular point gives a little bit confusion when you prepare for the questions. Whenever the charge or the lone pair of electron is involved in the delocalization, you just have to ignore the hybridization phenomena to decide the planarity. I just want to say the ring should be planar, outrightly how to take into the action. And also the ring should be cyclic conjugated. I mean to say the ring should be completely resonating with the pi electron system, and it must follow Huckel rule. Huckel rule says the ring delocalized pi electron should have 4n plus 2. So I am going to explain this Huckel rule. When you solve these pi electrons 4n plus 2, the n value should be solved for either 0 or 1, 2, 3, or can be any simple integer. And I just want to say, for example, if n is equal to 0, then we get the following, like 4n plus 2 pi electrons is equal to 4 into 0 plus 2 pi is going to 2 pi electrons. Therefore, the ring should have 2 delocalized pi electron system in it, then it could be aromatic. Similarly, if n is equal to 1, there should be 6 pi electrons. If n is equal to 2, there should be 10 pi electrons, and n is equal to 3, there should be 14 pi electrons. In just benzene, if you consider, it has a complete delocalized 6 pi electrons are there. 6 pi electrons are there. So when you solve this 4n plus 2, it is coming to be 6 and n is going to be 1. Like that you have to take. If it is not an integer, it is supposed to be maybe anti-aromatic. Like that you can say, not if more than 2 p orbitals are parallel, the overlapping simultaneously, there is a conjugation, and given one of them is filled with the other is vacant. And also the characteristics of the aromatic compound. So before I want to complete this aromatic characteristics, I just want to say the condition for the aromatic, 3 points, mind it: cyclic, planar, and complete conjugation, and 4n plus 2. These are the 3 major categories. And let us talk about the characteristics of aromatic compounds. In that they have a characteristic smell like any characteristic smell like annulene and toluene, they have their characteristic smell. Nitrobenzene is one of the chief ingredients, perfumes, and they extra stable. Aromatic compounds are super stable and they burn with sooty flame. And these are the 3 major fundamental characteristics of the aromatic compounds. Let us talk about benzenoid aromatic compound, and the aromatic compound which has a benzene structure or resemble structure in it is called as a benzenoid aromatic compounds, and the molecules having at least one benzene ring in the system, like you can see naphthalene, this is the structure of naphthalene, and anthracene and phenanthracene you can see. In that naphthalene you can see 1, 2, 3, 4, 5. There are 5 pi bonds. Each bond contains 2 electrons. Therefore, number of pi electrons are 10. And you can say anthracene, 7 pi bonds, 14 pi electrons. And phenanthrene, again 7 pi bonds, 1, 2, 3, 4, 5, 6, 7 pi bonds, 14 electrons. And also you can say anti-aromatic compounds. If the compound has cyclic, planar and complete delocalization, unfortunately it is not accepting Huckel rule, it is said to be anti-aromatic, and the anti-aromatic compound should have 4n pi electrons. And conditions for anti-aromatic, they should be cyclic, they must be planar, and they must fully cyclic conjugated, and there should be 4n number of pi electrons. Only the last point varies from the aromatic and anti-aromatic. There, the fourth one makes it compound highly unstable. Aromatic compounds are super stable, anti-aromatic compounds are utterly unstable. And I want to say, for example, 1,3-cyclobutadiene, you have just 4 pi electrons, right? And if you apply this is not equal to an integer, it is going to be 4n plus 2 is going to be 4 and n is equal to 1 by 2. So that it is anti-aromatic. And talking about non-aromatic, if any one of the conjugated and cyclic systems, planarity is missing and the conjugation is missing, such compounds are said to be non-aromatic. And you can see this is sp2 hybridized, this is sp2 hybridized, sp2 hybridized, sp2 hybridized, whereas these are sp3 hybridized. Planarity is missing. Whenever planarity is missing, it is said to be non-aromatic compounds. So non-aromatic compounds may be stable or may not be stable. Of course they exist. And if you check the stability of the compounds, order of stability, aromatic compounds are super stable than non-aromatic compounds, and anti-aromatic compounds usually they never be stable. And during a chemical reaction, if any non-aromatic compound is about to form, it never exists. And based on aromaticity, let us say which of the following is an aromatic compound. Like these compounds will be given, you need to identify. When this structure is given, it is a cyclic structure and the conjugation is there. And if we want to talk about 4n plus 2 is equal to total 4 electrons are there, and n is equal to 1 by 2. So it is anti-aromatic. And whenever you talk about this is a naphthalene structure, it is a cyclic structure and a conjugation is there and it's a planar structure. And 4n plus 2 is equal to total number of 1, 2, 3, 4, 5. Total 10 electrons are there. When you solve this, n is going to be 2. So it is said to be aromatic. Whereas you can see this structure sp3 hybridized carbon atoms are seen, so that planarity is missing, it is said to be non-aromatic. This is a non-aromatic compound. Of course, here also sp3 carbon atoms are there. This is also non-aromatic compound. Now, which of the following is an aromatic hydrocarbon? First one is said to be anti-aromatic. Second one is aromatic, non-aromatic and non-aromatic. I would say option B is the correct answer for this. Like these questions you are going to expect in NEET examination, children. And also based on aromaticity, which is the order of stability of the given compounds. Again the same kind of thing you can see. Analyze, this is an aromatic and this is anti-aromatic and this is non-aromatic. So based on that you can say this structure, it is a benzenoid aromatic compound. It has 14 pi electrons because it has 7 pi bonds and it is in the conjugation system, therefore it is said to be aromatic. And also as a cyclobutadiene, there is a 4 pi conjugated electrons in the plane and does not follow Huckel rule, therefore it is an anti-aromatic. And you can say this structure there are 4 sp3 hybrid carbons, therefore it is non-aromatic. So as we know, aromatic is more stable than non-aromatic is more stable than anti-aromatic. Therefore the structure 1 is more stable than structure 3 is more stable than structure 2. So in this session you come to know what is aromatic, what is non-aromatic and how to identify anti-aromatic and the order of stability of aromatic and non-aromatic and aromatic compound. And you can see out of these two compounds, let us say which is more stable. So trophylium carbocation, this is aromatic. This is also aromatic as far as this is concerned. Okay, but the total aromaticity makes the delocalization of the pi electron system. Aromatic cations are more stable than non-aromatic part. So this part is non-aromatic. So trophylium carbocation is extremely stable as compared to the benzyl carbocation because of the extra aromaticity is being added here. And so trophylium carbocation is said to be more stable, children. And one more question before we close this. Cyclopentadienyl anion is aromatic, whereas benzyl anion is not aromatic. So due to aromaticity, cyclopentadienyl anion is going to be more stable. So in today's class, we come across with the aromaticity and non-aromatic and anti-aromatic and how the concepts are being applied for looking at the stability of the molecules or the stability of the ions. Hope you enjoyed this session. Please like and share and subscribe this Infinity Learn NEET channel. Thank you very much.